You can do it. That's good. That's good. Perfect. All right, good afternoon. Nice to see you all again. This would be week 2. So hopefully if you had a Monday or a Tuesday morning tute lab, you rocked up to your tute lab. There was a tutor there and another tutor, extra tutor in the lab. This week is meant to be pretty gentle. There are still people swapping about and things like that, so we don't want them to have too much to catch up. And it's also a chance for you to get to know the other people in your class, your tutor to get to know you, and so on. So it's not a heavy week. We'll try to give you a bit more to do in upcoming labs. So, but there's some useful and interesting lessons from this week's lab and tute anyway. I'm getting a couple of email questions. Now, if you could see my email, you wouldn't be adding to the chaos that is my incoming email. We have a class forum set up. You should have received an invitation to your UNSW email to the class forum. Great place to ask questions. Tutors will answer them, students will answer them. There are a couple of tutors who've promised to keep an eye on the class forum and pretty much every waking minute. Well, I don't think they really promise that at all, but they seem to do that anyway. So there were questions asked over the weekend, and before I had a chance to get to them, Alex or Costa was fielding them. Great place for questions if they're at all likely to interest any other student. Yeah, sorry, there's a few things, few fiddly things going wrong, auto tests and so on. It'll settle down as we get everything working for the course, but then when we try and do new stuff, you'll have more problems. Patience is needed when new material's brought in. But again, an auto test doesn't work. Something's a bit confusing. The course forum, ask there. You'll get sympathy if nothing else. All right. Any questions of general interest about the course? Yep.
Are the files that you are working on will be made available to us?
The files that I've been working on, more or less, should be there under command line examples. I noticed the HTML on the web page is completely broken. Well, not completely broken, but partly broken. But if you click on command line examples, you, in theory, can get to all the files. If there are broken links or things like that, just pop a question in the course forum and it'll be fixed as soon as we can. But, sorry, the Harry Potter novels, J.K. Rowling still has copyright to, and will for a while, so sorry, they're not there. And that's, so today's, any more questions? So today's lecture, we're working through, I'll say a little bit, we're going to do an example with filters, and we'll work with Harry Potter again. I like Harry Potter, we all like Harry Potter. Don't say if you don't. And then we're working through into shell. Next week's lab is you do a bit more with filters, and then we get you starting to write some shell scripts. So, let's start on that then. What did I want to do first? Oh, I know what I wanted to do. So I'm always confused about how I'm meant to spell Hermione. So how would I find out? You're saying, Andrew, you've learnt about egrep. If you know the first, say, 4 letters, you can then search the whole file. So you can... You'll notice something wonderful here, by the way. If these were paper books, you can't do this. Electronic resources are amazing in this respect. All right, so that's doing something, but really I'm interested in words here. So I've got lines, and there are so many tools that we've seen already that work on lines. Sort works on lines, cut, unique, and egrep work on lines. So it'd be much nicer if I had one word per line. How do I do that? We haven't seen much to change things. But one tool we have seen is TR. You remember I showed you TR? So if you want to emphasize something, that says translate little a to big A, little b to big C, big B, and so on. So you can put in a message that's not too... something like this. And there, it's in uppercase. It's much more... Probably best not to translate your email to uppercase, but if you wanted to, there you go. I can also say to TR, change all the spaces to new lines. You can try that out. Get in the habit of trying stuff out. So all these filters, you may be working on files, but they all work from standard in as well. So you can try them out from standard in. So I can type in hello world. And the words have shifted to one per line. So let's see if we can get the Harry Potter novels I'll explain that question mark later in the lecture. Oh. TR is not coming to the party here. So TR is so old, it's a command so old, it doesn't follow the Unix filter model. It's expecting, it just goes standard in to standard out. Now, if I had one file, we know how to reuse I/O redirection to do that. How do we do that with multiple files, though? How do I get all the Harry Potter novels into one stream? Cat will do that for me. So I can say, Cat, here are some file names. Cat will get their entire contents and put them one by one under standard output. Not something you do much interactively, but tremendously useful for sort of these programmatic things. And then I can do this, say to TR, turn every space into a new line. All right, and here should be the Harry Potter novels. Word for, there we go. So now that's, we can check if that worked. Yes, there we go. It's maybe not perfect, but the million words of Harry Potter, one word per line, plus or minus. Yes, as soon as you start working with words, it gets a bit tricky. What's the mathematical definition, the incredibly precise definition of a word? That will come up when we have exam questions about words, by the way. If we have exam or test questions or just lab exercises about words, read the question very precisely, because what you think of as a word and what the question might be defining as a word may be slightly different. All right. All right, I'm on this. So now I'll search for Hermione. Ah, that's how it's being spelt. I wonder if J.K. Rowling's got Hermione's spelling right every single time. A million words, lots of Hermione's, not an easy name to spell. Did she get it right? Oh, and what about that comma too? Oh, and that apostrophe, yeah. All right, I know. I'll get rid of all the, I don't really care about the duplicate ones, so I'll get rid of them. So I'll do cat, pipe tr, pipe grep for the herms, and then I'll do a unique. Unique's broken. Why didn't unique get rid of all the, the Hermione commas, the Hermione apostrophe s's? Unique depends on, well, it works on adjacent lines only, doesn't it? So it just says, I'll merge two lines next to each other. Hopefully you went home last week and wrote unique in C. While if gets, if strucomp last line this line, sorry, strucomp last line this line, not equal to 0, print the line. Plus a few assignments. Maybe a stru copy. So what do I do here? What command, 99 times out of 100, precedes unique in any pipeline? Sort. We sort things. We know that if they're identical, they'll be adjacent. This should get me much closer to my goal. Oh, homie. Oh. All right, this isn't working for me. I need to split those up as words. So I said translate the spaces to new lines, but anything that's not a letter, say, I want to turn into a new line as well. And here, I'm going to show you a command that's enormously useful, but sort of not. I'll explain both of these things. Another Unix filter, sed, the stream editor. Given no files, it reads from standard input, writes to standard output, performing some editing commands. He's saying, what can it do, Andrew? Tell me, what can it do? And she says, it's Turing complete. And before he was being played by Benedict Cumberbatch, Alan Turing came up with a formalism for establishing whether programming languages were equivalent. Why is that amazing? This was the 1930s. How many programming languages were there in the 1930s? How many computers were there in the 1930s? The answer to both questions is 0. So Turing and a guy called Alonzo Church, a logician, American logician, established this notion of these languages being equivalent before there were computers or languages, well, useful programming languages. You've got to love mathematicians. So if a pure mathematician says to you, this will be useful in 50 years, they may be telling the truth. So we know, because when we say it's Turing complete, any program I can write in C or Java, I can write in sed. However, that does not mean you should do this. All right, sed I'm showing you basically for one simple command. Once you know Perl, which is a couple of weeks away, you don't really need sed, because sed's basically a subset of Perl for these purposes. You can put a Perl program on a single line. But until then, I'll show you what we can do in sed. Let's do it down here. The command I'm going to show you is just a replacement command. I can put a regular expression here. There. That says, and this is going to be a familiar sort of formalism, and you're going to see in a few places, that says replace this regular expression anywhere it occurs on the line with this string. Let's try it out. There we go. It only replaces the first occurrence. There are two, I'm going to show you two useful modifiers. One says ignore case, and one says do this every spot on the line. Oh, we'll do a cot as well. There you go. So you can put any pattern here. If I have let's say I've got what's that? That's 6 characters. How big a set of strings can I describe with a 6-character regular expression? What's the set with the most... the set with the most elements I can describe in a 6-character regular expression? I'll leave that as an exercise, but we know it's infinite. Those of you who know more maths than me will know about there's more than to infinity than a simple concept. I've forgotten all that. So here I can say any of this infinite set of strings replace with this replacement string. Nice. All right, I'm going to try and use it here for Hermione. All right, my plan is anything that's not a letter. Oh, not a letter. Oh, wait. I can say not a letter. I was listening last week to myself. This. Replace anything that's not a letter with a space. And the other thing I want to do is say that. All right, so that should change that annoying question mark, that annoying comma, that annoying apostrophe, exclamation mark and dot all into spaces, and the next TR should turn them into new lines. You're saying, could you merge those two? Yes, you actually can. It's a bit confusing, so I'm not going to do it. Let's see if that works. Oh. That's a bit worrying. JK's a million words, all gone. Wait a minute, I'll run it again. Again? No. All right. Is there an IDE for shell pipelines? I don't really know, but I don't think that's a good way to debug this. Can I put printfs in there? Yeah, not so easily. So I'm stuck here, aren't I? There's just no way out. Oh no, this sort of debugging is really easy. So what do? We back up the pipeline and see what we can discover. Nope. Nope. All right. So, where have all our herms gone? I know. All right, I'm on this. When in doubt, get your own data for debugging. Up past your bedtime? That's weird. All right. I think everyone spotted it now, sorry. What happened to the capital H? Case. I said everything but lowercase a to z. I think you would think it was obvious. You would think it would be obvious to say I want to include capitals. Obvious doesn't really work here, does it? It said does what you say, no more, no less. We could use the I modifier, but let me show you putting in that. Let's try that out and see if a Hermione makes it through in unscathed. All right. Wait a minute, where's my... Oh. Home loan. All right. We've got a way to find typos, spelling mistakes, or something like that in text. Interesting. So there's all the spellings of Hermione. As long as they start with H-E-R-M in there. Interesting. That suggests to me I could find out things about all the words in there. I could find out what J.K. Rowling's secret is. You remember I'm a little upset that, well, she's a billionaire and I'm not. She does seem like a nice person, but I could certainly use just a few of those millions. So maybe if I discovered what words she used, and I wrote a book just using the same words, I could make even 500 million would be good. So how do we discover what word she used? Up to unique. That's all the words she used, but I don't know whether she used zombie once or zombie 1,000 times. I don't know how. It suggests to me maybe I should be saying zombie in my novel if I want to get rich, but not how many times. Help me out here. Help me out here with a sentence, with a verb and a pronoun. So I'm going to be nagging about this. You get used to it. It's going to go on for the next 11 weeks. It's not sufficient to know the answer. You've got to communicate it clearly and precisely. So what you're trying to say is add a -c option to the unique, so that counts it. Yes, waving is not good either. You're sitting in the job interview with Google. Trust me, they don't want you sort of waving. Well, maybe they do. I actually haven't got a job with Google, so I'm not sure about this, but I'm guessing they want clear, precise communication. Oh, look at that. All right. So I'm not saying zone at all. Zoo, I'm going to say occasionally. Zooms, I'm going to zoom a bit. I'm a bit worried about these zis and zingingly, which are not real words as far as I know, but what now? Sort again. You sure? That's cat, said, tr, sort, unique, sort. Seems a bit excessive. Oh, what's the -n for? Numeric sort. This came up in the forums. I'm going to mention this in a while. You probably don't need the -n. Actually, let me just go. So give me inputs that show me the difference between sort and sort-n. Well, yeah, give me numbers or give me something to put in a file where sort and sort-n will behave differently. 11? Yep. Is that it? Sorry? Who said 11? Yep, and? 2? Is that enough? Yeah? All right, so we have a file. Wait a minute, let me check. Yep, that's good. Let me check again. Good. All right. Alphabetically, the file has one order, numerically another. We'll come back to that. Sorry, what do I put?
What if you try to sort numerically, but it has alphabet characters input?
Look, I don't want you to wear out your laptop, so I'll do it for you. There we go. Seems to order them. Yeah, that's an interesting question though, isn't it? What does it do when there's a mix of numbers? And yeah, interesting. I guess one moral would be you maybe not want to be depending on that sort of thing in the first place, but if it's sort of weird, sort of edge cases. The other thing would be go to man's sort, which I'm not going to do because I want to get back to Harry Potter. All right. Will this work? How do I just show the most popular word in the Harry Potter? Just the last one, tail. So what's the word going to be? It's probably isn't it? It's pretty boring. Oh. Oh. It's actually new line, I think you'll find, but, well, empty string rather. Sorry, an empty line. We changed all the spaces to new lines, so we've got all these empty lines. I want to get rid of those. Sorry, I'm not going any further until we get rid of those. How do we get rid of empty lines? Let's try out something down here. There are actually two obvious ways to do it with egrep. An egrep pattern that matches every line except an empty line. All right, he's going with dot star. Let's try that out. Oh, sorry, I've got this. Well, that's weird. That should work. Dot, double dot is a directory. Why is it saying double dot, grep double dot is a directory when I've said match the pattern dot star? I haven't said do anything to double dot or directories. I want it to read from standard in. I don't want to look at directories or files or why. The bash functions. You're getting there. If I'm Google, I'm not hiring you yet, though. I'm not sure you want to work for Google anyway. Not the best employer from what I've heard, but... Dot is a special character for shell. Is he telling the truth? No, he's not. But, right next to that dot is an asterisk. Yes. Well, we can test out the theory, actually. We're not mathematicians. We can experiment. I can say to the shell, don't interpret anything in here. See what that does. Oh, different behavior. So the shell is interpreting one of the things in there. And we can even find out which one it is. So we can go with his theory. His theory was it was the dot, same behavior. My theory is it's the asterisk. Asterisk to the shell doesn't mean its special meaning different to the one in regular expressions. That says match any files. So dot asterisk, the shell will attempt to match files. I'm not in my top level directory, and there won't be many. Dot and double dot. That's weird because they're not there. Dot and double dot. Did you do operating systems with Kevin in first session? No. Do you know the answer then? Who did operating systems with Kevin in first session, by the way? Anyone? Was it good? All right, I'd so recommend doing operating systems in first session. Oh, first term next year. But dot and double dot, you'll find out more about. They're things in the Unix file system which represent, dot is a name for the current directory, double dot is a name for your parent. So you can follow double dots to get right back to the top of the file system if you feel so inclined. It's Friday night, and like me, you've got nothing to do. You can sit there going cd double. Oh, I'll show you. Watch this. Watch this. So imagine Andrew home alone on Friday night. cd double dot pwd. Keep going. cd double dot pwd. No further. There are actually programs, quite a few programs that do exactly this. I'm at the root of the file system. I can go no further. So double dot is a synonym for your parent directory. I'm back there. I could have done... Oh, I did that. Sorry. Yeah. Did that answer your question?
Yes.
Okay. All right, so you wanted us to do this. All right, so we want it to match every possible string. It's going to take, testing them all is going to take a while, but not the empty string. Oh. Yeah, I'm the lecturer here. All right. What set of strings does that denote? Dot, any character. So we don't, if it's 7-bit ASCII, it's 128 characters. Unicode, a whole lot more. Asterisk, what does asterisk mean?
0 or more.
0 or more repetitions. What did you want to say there? Plus. And I've accidentally typed grep. I have to say egrep to get plus to work. You could say dot plus, couldn't you? And suddenly an empty line does not match. Can anyone simplify his regular expression for him? Because it doesn't have, as long as it matches some part of the line, it doesn't have to match the whole line. We could just say dot. That says just match a character. So if the line has no characters, it doesn't match. The alternative is grep's reverse option, -v, which says everything but the lines that match the pattern. So what's the pattern for an empty line? Let's try my idea first, which I'm warning you already doesn't work, which is just that. Oh, that's not good. It doesn't even believe it's a pattern. Pattern for an empty... Now, we've already said, when you're turning up in that job, you know, you want to be a Facebook engineer, and you're there waving your fingers about, they're not going to be impressed. It's a long way to fly to the US for a job interview not to go well, let me tell you. Square bracket, up hat, $, square bracket. Oh, that's interesting. Again, not quite right. Square brackets. What do square brackets mean? No, not you, not you. You've had your turn. Square brackets. How many characters does a square bracket sequence match? 1. So it's a way of denoting one character. But this is a truly bad piece of syntax, but we live with it because it's been there forever. That says not. So square brackets and an up hat means not. So that says match any character but the following ones. There's one following character that's $. So that says match any character but $. And we reverse the grep. So if I put dollars on the line, they go through. And if the line doesn't have a $, character, it doesn't. All right, someone help him out here. What was he thinking of for a pattern that matches an empty... No, someone else. Yep. Yeah, get rid of the square brackets. I know this all seems very confusing. Practice, lots of practice, using these, thinking about them, going back to the definitions, trying things out. You will understand this, and it will then be enormously useful to you for the rest of your life. You're saying regular expressions will be dead in 10 years. Programming languages may come and go, but regular expressions will last, I think.
What's so bad about the caret syntax for explicit matching?
Well, I guess that's really a subjective thing. That's my subjective judgment on how easy it is to read that. Though if you look at, I guess, the extensions to regular expressions, for example, in Perl, they're even worse. So maybe I'm just being harsh there. So this is a very common regular expression to see. That says match an empty string, or an empty line in the case of egrep. Right. We've beaten that to death. Let's get back to J.K. Rowling's. Where do we want to get rid of it? Maybe there. All right, so this should show me the word I've got to use most in my novels. The. All right, I'm going to be saying the an awful lot. All right, I'd like to browse through the words I should be using in order. But if I pipe this into less or more, which I don't know which you prefer, the pagination programs, it's giving me the... These are words I shouldn't be using. I can see why. Now, I don't think more has a reverse thing. So how can I view this in reverse order? Actually, someone asked in the forum about rev. We could try rev. Reverse is the line. Pity. Not quite what I want. Any suggestions? Sort has a reverse option. All right, so this should get me to going. So this is the secret to J.K. Rowling's $1 billion, using these words. So you just got to throw together mainly these words, maybe some Rons, a few Hermiones, the odd Dumbledore. Snape must come into here soon, surely. Oh, really? More Hagrids than Snapes, really? The odd Weasley. Ah, there we go. More Snapes than Weasleys. Now, did you know that? No, you didn't, did you? All right. Now, he's saying, Andrew, this is enormously slow. I could go home and write a C program that's 1,000,000 times faster. Yeah, I'm not sure you could. You could certainly write a C program that is faster, but do we care? So how long does this take to execute? It took about a second. So if he goes home and spends 5 hours writing a program that does this in 0.1 seconds, do we care? Yeah. It depends. Yes, good answer. All right, I'll leave you thinking about that. All right. So I've got this program here. It's a bit annoying to have it be typing it all on the command line. It'd be nice to be able to put it in a file and execute it in a file, wouldn't it? And we can do this. So let's go through a couple of steps there. Let's put you down. Oh, that didn't work. That did, though. I'm going to call it commands. There we go. All right, I've put the commands in a file. Can I run them? Yes, I can. Bash is the shell. I can say bash commands. I think it'll run that file. Oh, it does. By the way, that raises the interesting possibility of you can write a program whose output is shell commands, and then you can run the shell commands. That is actually a thing you do quite a bit. One of the advantages is, you've got to do some rearrangement of a file system or something like that with a whole pile of RMs and moves. You can generate the shell commands to do the job, inspect them, say, oh, yeah, that looks right, and then run them. So that was quite good. So a shell, like a lot of programs, lets you say, don't read your input from the keyboard, take it from a file. And that's where we're leading into for the rest of this lecture. The shell, it has two modes of operation, which results in it being less than ideal for, well, the second purpose, really. Shells are more tuned to interactive use, but they can be used non-interactively as a programming language. But this dual use means shells are limited programming languages. He's saying, are they Turing complete, Andrew? Tell me, are they Turing complete like SED? Oh, definitely. So again, you can write any program in shell, but that doesn't mean you should. I don't actually know if this will work. Let's try it out. Oh, wait. Permission denied? This is my laptop. How can it be denying me permission? I installed that operating system. It would be nothing without me. Now, you might not... I'm logged in as me. I'm not there as root. So you might know root... Unix systems have long had a very simple permission structure where you've got separate users who control their resources and there's one super user who can do anything. More recently, the more elaborate structures have developed in the last decade or so. But still, a lot of people work just this way. So I can log in as root, if I remember how to do this. Actually, the easiest thing is probably just Sue, isn't it? Do I remember the password? I think I do. Oh, look, I'm root now. We can check my ID. I can do anything. Commands. Oh, apparently not run that. Maybe it's confused about which file I mean. What? I'm root, and it's still denying me permission. Who would have thought that? Let's stop being root. Oh, so it's my laptop. Why do I use a separate user? Why don't I just log in as root who can do anything all the time? Why do I do what a lot of Linux users do? Just when if I need to do some system managers, whatever, I'll flip over to being root one way or another. But why do I normally act as a normal user on my own laptop, which hopefully no one else is using?
To prevent some risks.
What risks? Linux viruses really just don't happen. They're not that they're impossible, they're just rare. What happens if I type this as Andrew T?
I'm curious.
I'm not hitting return, no. I actually own a few things near the top of the file system, so it will remove a few files. I can accidentally type a command as Andrew T, and I probably won't do any damage. But if you do that as root, it'll dismantle the entire file system. So it's limiting permissions to prevent accidental operations. Viruses was a good suggestion as well. So if I'm downloading stuff or whatever. All right, let's come back to my commands file. Owned by Andrew T, group owned by Andrew T, 80 bytes, written at 424. They're not the problem. Sitting along here are the permissions. Which things? There are three triples there, which are read, write, and execute. Rightmost is anyone. Anyone can read this file. You can log onto my laptop, you can read this file. If Actually, it's not that simple. Directory permissions might stop you. Don't log onto my laptop. Group, anyone who's in that group. The last ones are for me. So they say, I can read the file, I can write the file, but I can't execute it. And again, we have these permissions for ourselves to prevent us doing things accidentally. So we can set files saying, occasionally you'll remove write permission for yourself from a file to try to reduce the chances that you accidentally change it. Similarly, this file doesn't have the last bit there, which is the X. And I can add that permission like this. Sorry, bear with me. And now I can execute this file. If you watch me chmoding files, you'll notice I'm far more likely to type it as an octal number. And that was done something slightly different. That will have said anyone can execute the file, anyone in my group can execute the file, and I can read, write, and execute the file. And away I go. Does this work? Oh, it does. I wasn't sure whether it would. All right. Now, there's a question about shells we haven't mentioned here. So I sit here, I type a command, and we talked about I/O redirection. So I can set byte streams for stood in, stood out, and stood air. I showed you putting in extra words which go in as arguments in argv. We're going to look at variables shortly. But we never said, where does the shell look for programs? So if I type date, how does the shell do that? There's a nice program which I don't know when we get to in lab exercises. You might not even get to it in lab exercises. So many useful programs, so little time. There's one program called find that will search a whole directory tree for you. So you want a file called Andrew. You can search the whole tree for it. Oh, it's complaining I don't have permissions and not finding the file. But that's okay. The shell doesn't do that. That would be too slow, though, to search the whole file system. There's a million files on this laptop. So when I say run a command, it can't search everywhere for it. So what does it do? It has a predefined set of directories which are in a variable. We'll come back to more about variables shortly. But it searches in those variables. And you can tell by looking at that, I've configured that myself. Every Linux user doesn't search home CS2041, for example, for files to run. So I've configured that myself. Telling it where to look. So if I just say, oh, that's interesting. I wonder if we can try this out. All right, I should have, bear with me, this may go badly wrong. I should have checked this beforehand. strace is this amazing program that lets you track system calls, requests to the operating system that another program is making. So I'm going to run a shell, and I'm going to say to strace, you watch that shell, you tell me what requests to the operating systems it's making. We're going to see how that turns out. All right. Oh, look at that. So all this output, don't freak out about this. All that output up there, you see it telling me stuff that the shell's done. So you can see there, it's accessed files. So I can discover that the shell looks in my home directory for a file called .inputrc. In fact, it found a file called .inputrc and opened it. How weird. Let me change the prompt. I wonder if that'll change any. Oh, that's strange. It's doing all sorts of things behind the things that happen behind the scenes in a program. You can see there I've got a history set up, and it's writing the command I typed into the history file. Weird. All right, let's try something simple. Let's try date. Let's scroll. Oh, look, it's checking to see. The shell is checking to see if I've got mail. It shouldn't be doing that, but it is. Let's go back in time. Oh, that's scary. So there's dynamic linking happening there. Yeah, that's really scary. Oh, I was hoping this would be simpler. All right, let's try this another way. Let's put the output from this in a file called system calls. Spell system calls properly. Run bash. I'll type the date command. We'll exit from the shell. And then watch this. I'll search for the date command, things that mention date, in this huge list of system calls. So you're starting to see why I'm teaching about egrep and regular expressions, if you haven't already. Let's do that with a more. That was sort of interesting. And there we can see the system calls, the request to the operating system the shell was making. I typed date, then the shell looked through this sequence of directories that I'd configured. It says, is there an import atoms 1 Andrew? Oh dear, that's not good. Anyway, that just doesn't exist at all on this laptop. Then it said, what about a home Andrew T bin date? Nope. It doesn't get discouraged. It keeps going through these directories looking for one that has a file called date, and it gets down to here. It says to the operating system, what about bin date? And there'll be a 0 return, which means success. It's saying, yay, I found it, I can run it for Andrew. So every time you do this, say you type something to the shell goes out looking for the program just like this. So behind the scenes, this is what a shell is doing. This is your life as a shell, if you'd like. The user just types in a few things and you've got to do all this work trying to work out what to do. So when it's got bin date, what is that? It is machine code for the date program. Those first few characters are sort of interesting, by the way. They tell the operating system what format the binary's in. You're saying, there's more than one binary format? Yes, sadly, yes. Binary formats are scary. But the first characters tell the operating system how to load this machine code into memory and run it. One of the things that happens that we're definitely not going to cover in this course is dynamic linking. So if you've done C programming, for example, you call code for, say, printf or something like that. That code may not be in your binary. It may be in another file which the operating system links in. What's the advantage of that? If you've got a million programs, sorry, let's say, I won't exaggerate, we've got 1,000 running programs that all you have the code for printf, we can just have one copy of the code for printf.
If we wanted to go down the rabbit hole of dynamic linking, where should we start?
Google. Because I don't have a good answer for you. No. No, I don't. I'd start at Wikipedia. Actually, Wikipedia is... You know, people come through school, and school teachers seem to be always, you know, saying Wikipedia is hopeless. You have to use things other than Wikipedia. But at least for this sort of topic, Wikipedia is typically a great place to start. But anyway, no. Actually, I don't really understand some of the things in dynamic linking. So You go away and Google a bit, and you'll know more than me probably. But it is a nice thing to try. Little C programs. See if you can set up static programs, dynamic linkings. Set up your own library. Google, see if you can set up your own dynamically linked library. That's really... So how did the operating system know this was a shell program? I don't actually know that. There is a convention that you'll see a lot of, which we probably should use. These two characters. So I mentioned the operating system looks at the first couple of bytes of a binary file, because there are multiple different formats for storing binary, for storing machine code, to find out which one it is and how to decode it. If it sees those 2 bytes, the ASCII for a hash, the ASCII for an exclamation mark, it assumes the file is not machine code, not binary. But it gets better. You can then specify the name of a programming language interpreter. And it will be used, the contents of the file will be passed to that interpreter. Now she's saying, Andrew, I've got my own programming language, which I've named after myself. Can I put that there? You can. So if you've got your own interpreter, you can put home Z1, 2, 3, 4, 5, 6, 7, 8, 9. That looks a bit right. But, oh, that's right. So you can put that there. If you've got your own programming language, you've got an interpreter for it, you can then run the programs. All right, we'll stick though to shell for this. So I can say that. In later lectures, we'll put Perl, Python, a few other things there. That should let me run the commands. Oh, right. Sorry, I've talked. I'm going to take a 5-minute break and give you a chance to stop listening for a little while. We're going to come back and more shell and talk about writing programs in shell. But 5-minute break. You can sprint to the loo or whatever. Sorry, I didn't mean to be... It's a good question. I actually don't know that much about dynamic linking. If you Google tutorials, you Google just plain example yourself, plain stuff dynamic linking, the static sync library we can see.
Also, I've got a question for you on the Slack search. Is Slack being good or email?
All right, let's launch back into figuring out how we use Shell as a programming language rather than just interactively. There was a really good question in the break, which was about labs. Someone was asking, you know, how much do I have to do to get full marks for the labs? Do I have to do all the challenge exercises to get full marks for the labs? So hopefully the labs are set up so if you do all this, I think the marking scheme I've got currently supposedly gets you, I think you have to do exactly one challenge exercise in 12 weeks and that will get you full marks if you do all the standard exercises. So you've all the standard exercises, but challenge exercise 1 week will get you to full marks. So in practice, you might get the odd standard exercise wrong, I guess, so you want to do a few challenge exercises. Some of the challenge exercises this week are not that hard at all. There's a challenge exercise that's really, really hard. The other thing, the lab exercises are set up so that if you miss a week, you can also catch up. It's like you saying, Andrew, can't you give me a formula? Well, the one question is, I'm not sure we're going to have a rest week. So in last session, we had a rest week. When the assignment was the second assignment was in full swing, we said, no lab exercises, there's too much happening. So if we do, I'm not sure we're going to do that again because I don't know what our second assignment's going to be, but it'll all be worked out. So the theory is, you can miss a week of the lab exercises and still catch it up on marks. Your tutors can adjust for missed weeks, by the way, too. And standard exercises will get you very close to full marks. That's meant to be. That's the philosophy. If it doesn't work out like that, we can adjust it at the end of session. You're saying Andrew, a better lecturer, would have it all sorted. Yeah, you're probably right. All right. Let me show you. All right, so we put these commands here. Let me just show you. There is one thing that's sort of nice. If you're writing stuff like this in a file, is you can break up the pipeline. You can put white space after the. Makes it a bit easier to read, really. So you can do that. Actually, we're already at, we're almost at a useful point for, I'll show you now something, we're at a useful point. I can show you something useful with shell. What people, when they start using shell, quickly discover is they have little utility shell scripts that just convenience things they do every day, and it's just convenient to have the shell commands in a separate file ready to go. So what they do is they configure their shell path. You're saying, how do I do that? It's typically a file called something like login in your home directory. No. bashrc. Yeah, it varies a bit. I think on CSE system it's bashrc. What does the RC stand for? I think it stands for run commands. But is that where oh no, I don't set my path there. Who knew? I think on CSE systems that's where you'd put it. It might be called that bash profile. Yeah, there I'm setting it. Maybe. What people typically do is they set their path to have one of their own directories in it, plus all the system directories. Good question. How many programs in these system directories? Oh. So there are 2,834 programs in these standard Linux directories that I can run. Who knew? Did you know that beforehand? You don't actually, because Linux, it's very easy to install a program. On the command line, it's just one line command to install. Someone tells you this program is great, and it's installed. I do it, but I don't have a network connection running, sorry. So they're all the programs in user bin that I could run. So I can run zip info. Oh, zip cloak, that sounds pretty good. Zip cloak. What does it do? Oh. Now ls, the file listing program, has options you tend to use a lot. So it's quite common to specify the L option, which is a long listing. We'll just do it here. Maybe you like the A option and the S option. There we go. I might get tired of always typing ls space minus las, running the command with those options. So creating a shell script gives me an option to avoid this. Sorry, it gives me a way to avoid this. Poor language. Let's suppose I create... Oh, I've already done it. Well, that spoils the punchline, doesn't it? Let's remove that. So in a directory in my path, I've got this directory where I keep programs called bin, a little misleading because not many of them are binary, but and I put a program in there. I can say ls minus las, and we'll do g as well. I can't even remember what g does. You can look that up. I've called that program L, and now I can say L and run that. So it gives me a nice way of getting a shorthand. I've called it a one-letter name and can have as many commands in it as I like. And you'll find people often do this just for something simple like that. But there's one more bit of the puzzle. ls lets me give it file names. So I want information on all the .c files in the current directory. I can type that. But my L command doesn't do that currently. I need some way to pass whatever arguments are given to my shell script through to ls. Now she's a Python programming. She's saying, Andrew, import sys and then give sys.argv1 to ls. Sorry, it's not how you do it in shell. It's a nicer way to do it, probably. Well, plus and minuses. How do you do it in ls? And shell, sorry. Everything of this sort in shell is special variables. Variables are denoted with $, and there are special variables. And in this case, what I want is really weird. You can go away and research why I want that. But $at, the at variable is the arguments. I guess at for arguments is the at sound. I don't know. That says put the arguments to the shell script there. So that should let me now and then just say pass those through. It works. Don't worry, we'll come to we'll cover a few of those variables shortly. But I want to come back to Harry Potter then. All right, so this program at the moment, it's a bit too special purpose. We programmers, we like generalizing, don't we? Rather than writing a tool that counts words in Harry Potter, we want a tool that counts words in any set of text files. There we go. So that says, get the arguments to this shell script, put them under standard out, pipe it to the sed, tr, grep, sort, unique, c. I think I had another novel here. Yeah, I do. Oh, maybe I don't. I thought I had a longer one. Oh, I thought I had War of the Worlds here. Oh. Wait, let me put a minus I here. Ah, in book. Look, did you see grep? Grep in use? I knew I had a file in this directory containing the text of H.G. Wells' War of the Worlds. There's all sorts of things in this directory, C files and things like this. But grep, egrep, my friend. And now I can analyze the War of the Worlds. We'll pipe that to more, and we'll find out how H.G. Wells, in this classic book, differs in word frequency to J.K. Rowling's. Well, there's no Harry there. Can we find the protagonist? Oh, interesting. No protagonist at all. Interesting. Martians, though. There were no Martians in J.K. Rowling's. Actually, you want to see something really sad? There's one Andrew, and mentioned once. I mean, who does that? It doesn't make any sense. How can you have a named character you mention once? It's just... So she made up that name and then just dumped him. If any of you is talking to J.K. Rowling, you ask her about that, really. All right. I suppose I should get back on topic. I like ending my shell scripts with the suffix .sh generally. Well, if you want to, you don't have to do that, but I do that because I like to be able to keep track of what files are what. Does that matter? Does Linux, the operating system, care if I have a C in a .c file? Is it okay to put my C in a say a .d file, .f file, .q file? Let's try that out. Move, what have we got, wc.c into wc.d, yeah. Operating system doesn't seem to complain, does it? What could go wrong here? GCC. What will GCC say? Whoa. I'm not sure what it's trying to do there. What does C-lang say? Oh, there you go. They're both trying to load it as a binary, I think, and link with it. So, suffixes in Linux, the operating system ignores them entirely. We have seen what the operating system does do. It will look in the first bytes of a file if you try to execute it. Doesn't look at the suffix. Doesn't mean, but particular programs may look at suffixes. And certainly any sane person uses useful suffixes. All right. Let's look at a couple of variables. $1 is our first argument. $hash is what else? Oh, Echo. Have I mentioned Echo explicitly? Echo is a great C program. You can go home and write this in C or Python. It takes its arguments and just writes them to standard output. You're saying, that's easy, I can do that. Yeah, you can do it in one line in Python. C, it's 4 or 5. And it doesn't get used interactively unless you're sort of sad and lonely like me. So you don't normally sit at the keyboard typing in Echo. It exists to be used inside shell scripts. What else? $dollar question mark. So there's a few special variables. Oh, and I'll give you one more. All right. Variable dot sh. Why me? Why? All right, help me out here. There's a dash there. What would I like to see there? Short of binary editing the block device to the character device for the file system, maybe this would be better. All right. So we'll give it 3 arguments. So $0 contains the script name. Why would you want that? Why would you want to know your own name? Why? You can do it in C. In C, can't you? argv0 in C, argv0 in Python. Sorry, sys.argv0 in Python. Why? What possible use is knowing your own name? What's my motive? Let me tell you one of the many things about this world that annoy me. I'll just tell you one. One is when you've got running some huge installation script or something like that, and an error message pops out. But it's 5 levels down, and you've got no idea which program is actually producing the error message. So good programs include their name in error messages to make it easier to find out where the error message is coming from. So that's one reason you can use your name. Sometimes programs look at their names and behave differently depending on what name they're called. And you can do cute things there. Sometimes programs use their name to get where they're sitting in the file system and then use that to get at other files. So they're location independent in a file system. Oh. So those 2 highlighted echo lines have produced the last 2 lines of output there. Why? Why? How did that happen? Why? The variables $, and question mark we'll talk about shortly. But what happened to my question mark there? It turned into a D. How can that happen? Doesn't make any sense. Hypotheses.
There's a file called D and it's such for that.
Start me off a bit slower. It's been a long day. Question mark.
Question mark is the shell reads that and then it's got a file.
Shell reads the question mark. Yeah, we knew that. And the question is, does the shell attach a special meaning to the question mark? That's what you're telling me, isn't it? And you were telling me what the special meaning was, but as I said, it's been a long day for me. Oops, I didn't write the file. Let's try again. So part 1 of your hypothesis is confirmed. If I put little quotes around it and say to the shell, no special interpretation. Don't look at, well, what characters do we know if the shell space has special interpretation on? Asterisk, $, space, so the 3 we've definitely seen so far. So don't look, I actually mean a question mark. So what was your second part of your hypothesis?
The special meaning is that it looks for a file, in this case, with like a single character.
So I can confirm your hypothesis. Well, wait, I've got a better way to confirm your hypothesis. So I've created a file called E. How will that confirm his hypothesis? Oh, look there. So if I say question mark, the shell expands that to mean 1 character in a file name. It's quite nice. So if I want file names with a single character suffix, I can say star.question mark. Weird. Oh, look at that. Yeah, nice. All right, but we wanted a real question. Well, actually, oh, I know it. What I should have done is this. A good lecturer would have had this. And again, you're saying, Andrew, but question mark has a different meaning in regular expressions. Yes, it does. Shell 1 meaning, regular expressions the other. Asterisk, shell 1 meaning, regular expressions the other. Sorry, just bear with me a second. for that question answer, we'll have the first Mars bar of the season, of the lecture. If I can get into the... Well, actually, they're not Mars bars. They're all the equivalent, carefully made as similar as Mars bar as their team of intellectual property lawyers will allow. And they have a very good... Oh, no. You're way up there, aren't you?
Yeah.
Oh. I can throw, but I also know from my physics that I have to be thrown at about 80 kilometres an hour to get a parabola that doesn't intersect the roof. All right, but I'm going to throw it to the big guy in the road there, and he's going to throw it back to you. Are you ready? I can reassure you, I had many students who have been completely uncoordinated, judging by their catching of Mars bars, who've done very well in this class. So oh, come on, at least make an attempt. Long ago when I was a tutor, I used to take a cricket ball along, well, I didn't do this very often, I'd take a cricket ball along, I'd toss it to the person whose turn it was to ask a question. I think I only did that for 2 tutorials before I discovered that was a very bad idea. Anyway, all right, enough of my complaining. 2 special variables. No Mars bars for these. This is a bit esoteric. $. What's $?
The process ID of the SH process.
Yes, it is. So you're saying, I'll memorize that for the exam. Sorry, there's not going to be marks for that. It's a useful thing to use when you're creating temporary files. We'll see that actually next lecture, I think. So unique number identifying this process. How many bits in it? Any good programmer sees a number and asks how many bits. All right, and $? Is the exit status of the last command. It's what. So you remember, if you've just done first year, you've just done Comp 1511. There are all these programs that went return 0, return 0, return 0 in main. That's the value that the last program returned, and shell programs use it. We'll come back to that. Questions about that? Quickly, because I'm going to move on. Yes, I know you've had a long day as well. All right. So let's look at assigning to a variable. I should try that out. Oh, it's a hash. Oh, well, we're on that. That's actually quite good. Hash is the shell comment character. So there's a comment there. That was actually a typo. So there's a program with 2 variables in it. So questions occur to me. First, syntax of names. Similar to C identifiers, you can research the slight differences between C or Python identifiers if you like. Assignment with an equals. Oh, types. So it's not like C where I have to say int x, float star y, char array. No types on variables. You might be thinking, it's like Python with types on values. It's just no types, really. The only variables you really have in true shell, core shell, the subset of shell we're going to look at is just strings. But this bit's a bit weird. I have to put double quotes around Python. I have to put double quotes or single quotes around the string. C, I have to put quotes or double quotes around the string. Those are strings. Why didn't I have to surround them with quotes? Why have they chosen not to insist on that? Creates all sorts of possibilities for errors. Why? Because of this dichotomous use. the shell was set up to be used interactively. We're all lazy, and when we're typing interactively, we want to do things with a minimum of typing. So we don't have to. Well, let me show you. Do you really, when you're typing in, want to have to type in, say, GCC minus wall Fred.c? I think not. I think and I've got the quotes wrong. That would be even more annoying. So obviously, when you're typing interactive, you don't want to use quotes, even though these are strings. Well, GCC is the name of a program. It is a string. But the other things are just strings to be passed into argv, aren't they? That says run GCC with argv1 being dash wall and then terminating null and Fred.c. Be argv2. You're saying, Andrew, I'm a careful, pedantic sort of person. Can I put quotes there? Yes, you can. No one's going to criticise you for doing that. Does the same thing. Difference between double quotes and single quotes. Let me show you this. All right. As I said, it's been a long day, but try to keep those neurons going for just a touch longer. This is important. You'll see it in several contexts. We have a double quoted string, and I'm using echo to print it out, and a single quoted string. Between single quotes in shell, there is no interpretation. Between double quotes, there is very little interpretation. Precisely, something looks like a variable. Between double quotes, it's replaced with the value of a variable. So basically, if it's a word preceded by a dollar, it's replaced with the value of the variable. Back quotes between double quotes are also specially interpreted. We haven't seen back quotes yet. What's the difference between, I know there's some good Python programmers here. What's the difference between double quotes and single quotes in Python? Are you sure about that? Stake your life on it? Give me $100 if I can know a difference between double quotes and single quotes? I was actually curious. I'd actually know why there is no difference between double quotes and single quotes. As far as I know, there is no difference. But C, of course, they're very, very hugely, gigantically different things. All right. What do I want to do now? I'm going to look at my slides. There must be something on my slides. Oh no, let's switch to the shell slides. Sorry, bear with me. All right, so yeah, I'm talking about there are lots of shells out there. This guy's going to go home tonight and write his own shell. Not such a silly thing to do, by the way. I'm sure one or two of you will write your own shell in the upcoming years, and lots of people have. So there are hundreds and hundreds of shells out there you can use, all sorts of, and some of them, there are, I don't know, a dozen at least in common use. So what shell are we talking about in this course? I'm trying to teach, we'll try and cover the set of shell syntax that works in any shell. And I'm cognizant, I'm thinking of two particular examples. Bash is the most popular interactive shell on general purpose systems. But Bash has had a lot of, it started off as a small set of commands similar to other shells. It's had a lot of features added, so we're not going to go through all the possibilities. For example, Bash supports arrays, regular expressions, and things like this that we're not going to cover. We'll cover the intersection between Bash and a shell called BusyBox, which is a tiny, tiny shell designed to take up the minimum number of bytes of code. So it can be done. Did I mention I think my remote control on my TV has a shell inside it? I haven't mentioned it. I think it does. And it'll have BusyBox inside it. So BusyBox is something is a shell you'll encounter in embedded situations. It's actually quite nice. It might surprise you. You think I'd do everything in C, but BusyBox plus shell scripts has a small footprint. If you're trying to get something down as fewer bytes as possible, so it'll fit in a remote control, it's not a bad solution. You want to get your Python interpreter and packages and things there? No. Perl's not much better for that. C, if you're really careful, yes, but often you'd prefer to be working with something like shell. Can you run grep in your remote control? Maybe. You can find. Certainly my TV, I have quite an old TV, has grep in it. How would you know though? Really, how would you know what's happening in your TV? You can wake up tonight worrying about that. All right, we talked about. Oh, yeah, exactly how the shell does and splits up a line. We'll have to come back to. It's actually important to know exactly how it breaks up a line. So we'll waffle a bit and come back to that. Yeah, we talked about this. Talked about that. Ah, all right, arithmetic. So one of my favorite programs is one called Explorer. It exists, again, not generally for interactive use, for use within shell programs. So you can put something like, oh, actually, no, let's 20 plus 22. And he's saying, Andrew, be careful. Is plus a meta character for the shell? Does it have a special meaning? How would you know? Well, if in doubt, quote it. I think I'm okay there, but let's find out. She's saying, Andrew, I'm going to go home and write that in Python. I would recommend it, but beware of one thing. Oh, you've got to get precedence. Don't forget fourth class with BODMAS. You've got to work out how to do that. It's a nice little programming exercise, actually. So what does that print? Get your phone out. 42 times 3 is 100 and... Saying, Andrew, it's almost 6 o'clock. Oh, no. So plus isn't a shell meta character, but we all know asterisk is a... So what did Explorer see? We can find that out by just saying to echo. So this is what argv actually looked like to Explorer. Explorer doesn't know what I typed. I guess it could go out and poke around the shell or poke through memory. You could do hacker things to sort of find out. But if it just looks at argv, it doesn't know what it types. It's just given argv. And the shell sees the asterisk and pops into argv all the file names in the current directory. Is that true, by the way? Does asterisk match all the file names in the current directory? Not quite. You can research that. Almost all the file names in the current directory. So I guess Explorer could say, get the list of file names in the current directory, then compare it to its argv and say, Andrew, I think you typed an asterisk by mistake. But that would be a bit silly, I guess. This is quite useful. We'll find out whether asterisk between double quotes gets evaluated. No, it doesn't. Ah. All right. So I've got a program that will do arithmetic for me. I have to go and write, she's writing it in Python, he's writing it in C, he's a big Ruby fan, he's writing it in Ruby. We don't really care. Expr is out there. Oh, where is it out there? We might be able to find out what it's written in. Sometimes compilers leave behind. Strings is a program that looks through a binary file for ASCII and just reports it. That's a bit scary. We know it's a GNU program. Interesting. All right, that's not helping us out there. Now, my problem is, I've now got a way to do arithmetic in shell. I've got a command that will do the arithmetic, but I want to get it back into a variable. You're saying, how do I do that, Andrew? I'll show you the classic way to do that, which is this. Back quotes. Back quotes are so different to single quotes. Double quotes and single quotes are almost the same in shell. Not much difference. Back quotes are hugely different. They say, what's between me is a command. Run that command, get whatever's on stood out, 1 byte, 1,000 bytes, a gigabyte, and to put it in a string, and then then I can assign that string to a variable. Let's try that out in my example program. So I've got stood out from the date program and put it in the variable x. So I'm on this. Let's do some arithmetic. X equals 6, y equals 7. Answer equals $x, and I learnt my lesson, I'm quoting the asterisk, $y, back quotes, pass this all to the extra program, type it properly. $42. So there's a way of doing arithmetic. All right, a plus. That's a nice new laptop. It's a year old. How long does it take to add together two 32-bit numbers? I don't actually know myself. Picosecond or something like that. For those of you who have done operating systems with Kevin, most of you still have that delight ahead of you. How long does it take to run another program, launch a program under Linux? Not one instruction. We're talking, Linux is heavyweight, so we're talking tens of thousands of instructions. So an addition is one or less than one instruction. Launching another program is at a minimum 10,000 instructions. So shell arithmetic, if we think about that, must be at least 10,000 times slower, probably 100,000 times slower, done like this at least, than in, say, a C program. Does that matter? If it takes 0.1 of a second instead of 0.00001 of a second to run your program, you don't care. But you're not going to be, doing the next great climate model for Australia using shell. All right, there's more. I'm halfway through showing you syntax here, so there's lots more to show you here, but the lecture recording cuts out in 5 seconds, so I can't tell you anything more.